Good evening everyone, myself Gautam Sharma. I welcome you all in a Sapiens Education. So this is part 6 video of the ray optics. So today I am going to discuss about the lens maker formula. So before that I will describe about the types of lenses. So let us consider there are two types of lenses, that is convex. So we should describe about the convex lens. So let us consider this is your convex lens. So convex lens will appear like this. So this is your convex lens, got it? And let us consider a ray of, this is a principal axis. So if you try to complete this sphere, because lens is also a part of a sphere, right? So you will get a sphere like this. This is F. This is optical center, that is C. This is also optical center C, and in between there is a F. Not a optical center. This is a center of curvature, and this is a focal length, right? This is a focal length. Now a ray of, what will happen? A ray of light which is parallel to the principal axis. So what will happen? It will always pass through the focus like this. One ray of light which is passing through the optical center will pass thoroughly. So these are the things you have to remember. So when we talk about the first layer, so first layer has a radius of curvature in this direction. So this is R1. And R1, if you talk about the R1, so R1 will be positive only. If you talk about the focal length, so focal length is in also in this direction. So focal length is also positive. And if you talk about the R2, that is R2 is in this direction, so this will be negative, right? So when we talk about now concave lens, so let us talk about the concave lens. Concave lens. So we have lenses like this, lenses like this. So these are the lenses. These are the lenses. This is optical center. This is an optical. This is center of curvature. So for this part, this side there will be a center of curvature. So this is a C1 and this is your C2. And a line which is passing through this both will be considered as a principal axis. We have a focal length here, f1, f2, and when we talk about the radius of curvature, so this is r1, and when we talk about this is r2. So r1 is negative because it is kept here, r2 is positive, and focal length is also negative. So this is all sign convention you need to remember. So I hope you have understood this. Now let us derive lens maker formula. Lens maker formula, with the help of this formula you can we can able to, or lens company able to make the lenses. Let us consider, let us consider this is a convex lens. Okay, let us consider this is a convex lens. This is an optical center. This is a principal axis. This is a principal axis. Okay, so let us consider this is a center of curvature. that is C2 for this lens, and this is also center of curvature for C1. An object is kept at this point. Okay. Now O indicates an object distance. O indicate object. Now when a light rays coming from object, so what will happen? For this surface, the center of curvature, when we talk about the center of curvature, so definitely this the center, when we talk about this part, and if we talk about the normal, so let us consider the normal lie on the normal should always lie from the center or pass through the center of curvature. So from here we can get an angle of incidence. So this is an angle of incidence I. Now if there will be no lens, so this light should go like this, but due to this lens, so it has bent like this, and bend when it bends, so it has made an image. I'm not talking about this right side, right part, so just I'm talking about the left part of the lens. So due to its bending, so it has made an image at this point, and this image is considered as an I1. Got it? Now, now when we talk about this, see here, but it is not the final image. Why it is not final image? Because it has to pass through this layer. So it means that this layer, for this layer, this I1 will act as an object. So earlier this object distance was U, and the image distance was V1 for the case 1. And if we talk about this one, and object is at a rarer medium, and object is at rarer medium, and it is passing through the denser, it is passing in the denser medium, so we can use this formula, mu1 by u minus mu1 by u plus mu2 by v1 is equal to mu2 minus mu1 by r1. Got it? So this is definitely equation 1. Now we talk about the phase 2. Phase 2 means, when we talk about the phase 2 means, when we talk about the phase 2 means, this this image will act as a object for this layer. So this when this image will act as a this image will act as an object distance for this layer. So what will happen, it is going from denser to rarer medium. So when it is coming to this surface, and we are talking about the normal, so when we talk about the normal, so what will happen, it will bend away from the normal. So what happens, it will bend toward normal like this, away from the normal like this. So let us consider this is the light rays. So final image it is forming, so the final image it is forming is here only. Let us do it. See, this is the final image. So let us consider, due to bending it has formed a final image I. So final image is equal to V. Got it? And for this layer, I1 will act as an object. I1 will act as an object. So we can use this formula. Again, we can use this formula, minus mu2 by V1 plus mu1 by V is equal to mu1 minus mu2 by R2. So because object is in denser medium, denser medium, so we have to use this formula. Now combining both the formula. So when you combine both the formula, when you combine both the formula, so we can get minus mu1 by u plus mu1 by v is equal to mu2 minus mu1 1 by r1 minus 1 by r2 is equal to mu2 by mu1 minus 1, 1 by r1 minus 1 by r2. And we know that we can get this formula. So these are the formula I have already derived in the previous section, is previous section. So you can go and pause the video and go to the previous section how I have derived this formula. When an object is at a rarer medium and passing in the denser medium, so this formula will be used. When an object is in denser medium and passing through the rarer medium, so we can use this formula. And after this formula we have got this result. Now let us consider an object is at infinity, that is u is equal to infinity, then image is equal to focal length. So by this 1 by f is equal to mu2 to the power 1 minus 1, 1 by r1 minus 1 by r2. So this is the formula, and this is known as lens maker formula. Lens maker formula. Now you are thinking that why this is considered as a lens maker formula. We are considering this as a lens maker formula because if you want a lens of a desired focal length and of a desired radius r1 and r2, then you can change up and down to get the desired result. So in your manufacturing process, you have to use a certain material which has this refractive index value, so that you can get the desired focal length. So as per the focal length, it has been decided that how much radius of curvature we have to put, how much refractive index we have to put. So I hope you have understood this lens maker formula. So lens maker formula. So finally I have completed this lens maker formula. I will again come to the next section. So for more, you should be connected and watch my video. Thank you for being here.